Hello viewers, today in this video we are going to see how do metals and non-metals react with each other, because in our previous videos we have seen the properties of metal as well as non-metals. Now we are going to see how metal and non-metal react with each other, right? So that we are going to see. So first of all, any of the metal or any of the non-metal, why they are reacting? Because before how the question is arising in our mind that why the metal and non-metals react with each other. So answer of this question is studied in 9th standard. In 9th standard you have studied the electronic configuration of any given element, and while you are studying electronic configuration, at that time you have studied the octet electronic configuration. Now let's recall it. What is the octet electronic configuration? The outermost orbital, any element having its outermost orbital, if it is fully filled, then it is considered as the octet electronic configuration. If it is not fully filled, then it will try to complete its octet configuration. So in that case we have seen that if either any of the element having 1, 2 or 3 electron in their outermost orbital, then they are used to donate that electron, because they are not able to gain 5, 6 or 7 electron to complete its octet configuration. Octet configuration means in outermost orbital completely filled with 8 electrons. But as if it have electron in outermost orbital is 1, 2 or 3, then obviously 1 electron required 7 more electron to complete its octet configuration. Exactly same way, 2 electron in outermost orbital element will require 6 electron to complete their octet configuration, and same way 3 electron in outermost orbital element will require 5 electron to complete their outermost orbital. But that would not be possible. So what will they do? They will donate the electron. If 1 electron is there in outermost orbital, it will donate 1 electron and gain a positive 1 charge. 2 electron, then 2 it will be donated and having plus 2 charge. And if 3 electron is there, then 3 electron will be donated and it will have the plus 3 charge. Exactly the same way, if any of the element is having either 5, 6 or 7 electron in their outermost orbital, then they used to gain the electron. And while any of the element gaining the electron, at that time they are having the negative charge, right? And what about the element having a 4 or a 8 electron in their outermost orbital? See, if the element having a 4 electron in their outermost orbital, then it is called half complete orbital, which is quite stable. So generally they neither donate the electron nor gain the electron in general cases. And if the element having a 8 electron in its outermost orbital, then that element is stable element. It having a complete octet configuration. So it is stable and inert. They don't use to react with any other element, right? So this is the basic fundamental concept of the electronic configuration that we have already studied in 9th standard. On the basis of that, on the basis of valence electron, here we are going to see that how metals and non-metals reacting with each other. So here, first of all, we are going to take the example of sodium. Now as you all know, the atomic number of the sodium is 11. So its configuration is 2, 8, 1. It means 2 electron is there in K shell, 8 electron is there in L shell, and 1 electron is there in M shell. Now as I have told you, as it contains 1 electron in its outermost orbital, so what it will do? Obviously it will donate that 1 electron. So here you can see sodium donating 1 electron and consuming positive charge, right? Okay. Now same way, if we are talking about the chlorine and its configuration, then atomic number of chlorine is 17. So the electronic configuration is 2 electron in K shell, 8 electron in L shell and 7 electron in M shell. As you can see here, the M shell is its outermost orbital and outermost orbital containing 7 electrons. It means it will require 1 electron to complete its octet configuration. So what it will do? Obviously it will gain 1 electron. So here as chlorine getting 1 electron and converted into a negative charge, that is Cl minus. Now if you are going to see the Lewis dotted structure, then here you can see sodium having 1 electron in its outermost orbital while chlorine having 7 electron in its outermost orbital. Now to complete outermost orbital, chlorine require 1 electron and here sodium having extra electron in M shell. So sodium will donate that 1 electron to the chlorine. So what happened? Chlorine complete its outermost orbital, as well as by donating this 1 electron, sodium has been also completed their outermost orbital. Like this way they are preparing the sodium chloride compound. So by this way the elements, that is the metal which is the sodium and non-metal which is chlorine, react with each other to complete its outermost orbital, or we can say to complete its octet configuration. Either they are donating the electron or they are gaining the electron, and by this way they combine with each other and form a new compounds. One more example let's take. Here the magnesium. If you are going to see the electronic configuration of magnesium, then its atomic number is 12. And because of its atomic number is 12, its configuration is in K shell 2 electron, L shell 8 electrons and M shell there will be 2 electrons. So M shell will become the outermost orbital. So here there is a 2 electron in its outermost orbital. So obviously it will donate that 2 electron. So here Mg going to donating 2 electron. So it will have the +2 charge. Now when this Mg going to react with chlorine, then what happen? Once again I am explaining you with the dotted structure. See, this green color dot is the electron of chlorine. So electron of chlorine, sorry, in outermost orbital of chlorine there will be how many electrons? 7 electrons, which I have dotted with the green color ink. And Mg having a 2 electron in its outermost orbital. So 1 electron is donated to one chlorine and another electron is donated to another chlorine. So that's why what is the formula of magnesium chloride is MgCl2, not only MgCl, but it will be MgCl2. Why? Because Mg donating 2 electron, right? So like this way elements, means metals and non-metals, react with each other to complete its octet configuration, right? Okay. Now we are going to see that this kind of compound is considered as the ionic compound. Why it is known as the ionic compound? Because after gaining the electron or donating the electron, they are having some charge. Suppose metals donating the electron, they are having the positive charge. Same way, non-metal gaining the electron, so they are having the negative charge. So positively charged metal attracted by negatively charged non-metal, and they will combine with each other, aggregate with each other, and this aggregation is because of the oppositely charged element, and that's why these are the compound which is known as the ionic compound. Why? Because ions, positive ion and negative ion, aggregate with each other because of the strong electrostatic force, and that is the reason the compound is also known as the ionic compound, right? So here we are going to see some of the properties of the ionic compound. So let's see the properties of ionic compound. First of all, let's talk about the physical nature. So generally physical nature means state, whether it is a solid, liquid, gaseous, whatever. So generally the physical compounds are solid in nature and hard. Why it is hard? Because they have aggregated with each other with a strong electrostatic force, and that's why they are comparatively harder in nature and obviously solid in form. Next we are talking about the melting and boiling point. So obviously they have aggregate with each other with a strong electrostatic force. So obviously it is difficult to remove them, it is difficult to separate them. So you have to apply more heat to separate them or to remove them, or we can say to break the bond. We have to provide and more energy in form of the heat, and that is the reason their melting point and boiling point are comparatively very high. Next property is solubility. See, generally all the ionic compounds are soluble in water, and once the ionic compound soluble in water, then that kind of solution we are known as the aqueous solution. But they are insoluble in certain solvents like kerosene, petrol, etc. Now the last property of the ionic compound is conduction of electricity. See, in a previous video also we have seen, for the conductance of electricity, it will require either the free electrons or a free ions. So here, obviously ionic compound itself, it is made up of the ions, but in a solid form, when the ionic compound is in a solid form, the ions are not free to move because they are rigid. So they are not able to free to move to conduct the electricity. So we can say that the solid ionic compound not able to conduct the electricity. But if you prepare the aqueous solution of ionic compound, it means ionic compound dissolve in water, then what happen? Ionization will take place and ions are free to move. And as the ions are free to move, obviously it will conduct the electricity. So we can say that the aqueous solution of the ionic compound shows the conductivity of the electric current, right? So that is some basic properties of the ionic compound. In our next video, we are going to see the extraction of metal, how the metal can be obtained from the nature. That we are going to see in our next video. Till that, stay safe, stay at your home, and thank you viewers.